Good morning, all of you. In this session, I am going to explain about centroid of different Z sections. Okay. In this class, I will explain how to locate an centroid or center of gravity of an Z section. Okay. In this session, I will explain about these three cases. Okay. So these three are different Z sections. Okay. It is very important for exam point of view. Okay. In first case, I will explain about this Z section. In second case, I will explain about this section. In third case, I will explain about this section. Okay. I will explain one by one. First of all, you have to know the fundamentals about centroid of an rectangular cross section. Okay, let B is the base of a rectangle. D is the depth or height of a rectangle. Okay, now I am drawing the diagonals for locating the centroid of a rectangular cross section. Okay, this intersecting point indicates the centroid or center of gravity of a rectangular cross section. Okay, here you can observe this centroid always lies at the distance of half of the base and half of the depth. Okay, like this. So by using these fundamentals, you can locate the centroid or the center of gravity of an Z section, I section, L section, and the T section. You can locate any type of rectangular cross sections. Okay. Now this is case one. Locate the centroid or center of gravity of the given Z section. Okay. So these are the given dimensions. First of all, you have to convert the given Z section into three rectangles like this. Here I consider this bottom rectangle as a section 1. Okay, the base of this bottom rectangle is B1 equal to 100 mm. Okay, and the depth of this bottom rectangle is D1 equal to 20 mm. Okay, now I consider this middle rectangle as a section 2. Okay, base of a second rectangle is 20 mm, and the depth of this middle rectangle is D2 equal to 60 mm. Now I consider this top rectangle as a section 3. Okay, so here D3 is the depth and B3 is the base of the third section. Okay, for locating the individual centroids, you have to consider reference x-axis and reference y-axis. Okay, now this intersecting point is the origin. Okay, now you have to locate the individual centroids based upon the origin. Okay, now here A1 is the area of the bottom rectangle. Area of a rectangle equal to base into depth. So B1 into D1 equal to 100 base by 20 equal to 2000 mm square is the area of a bottom rectangle. And here B2 equal to 20 mm and depth D2 equal to 60 mm. So A2 is the area of a middle rectangle. Okay. So A2 equal to B2 base 2 into depth 2 equal to 20 by 60 equal to 1200 mm square. Now this is the third section. Depth D3 equal to 10 mm and base B3 equal to 120 mm. Okay, A3 is the area of a top rectangle. A3 equal to base into depth. So the value is 1200 mm square. 120 by 10 equal to 1200 mm square. Okay, these are the individual areas. A1, A2, A3. Now I am considering the x-axis and y-axis. Okay. Now here you can observe the total base B3 equal to 120 mm for top rectangle. Okay, for identifying this gap, you have to subtract this 20 mm from this base B3. Okay, so 120 minus 20 equal to 100 mm. Okay, this gap is 100 mm. Okay, now I am drawing the diagonal lines for locating the individual centroids for rectangular cross section. So this is the C1. C1 is the centroid of a bottom rectangle. Okay. Now x1 is the distance of a centroid C1 from y-axis. That value equal to gap 100 mm plus half of the base. Okay, here the base B1 equal to 100 mm. So you have to consider half of the base 50 mm plus gap 100 mm. X1 equal to 150 mm. Okay. Now I am drawing the sorry here y1 is the distance of centroid C1 from x-axis. Okay. Now I am drawing the diagonal lines for second rectangle. C2 is the centroid of a second rectangle. X2 is the distance of a centroid C2 from y-axis. That value equal to gap 100 mm plus half of the base 100 plus B2 by 2. Okay. Now y2 is the distance of a centroid C2 from x-axis. Okay. Y2 value is equal to depth of a bottom rectangle plus half of the depth of a middle rectangle. Okay, D1 plus D2 by 2. Okay, here D1 equal to 20 mm, D2 equal to 60 mm. So 20 plus 30 equal to Y2. Okay. In similar way, I am drawing the diagonal lines for locating the centroid C3. Okay, C3 is the centroid of a top rectangle. X3 is the distance of a centroid C3 from y-axis. Here x3 equal to half of the base of a third rectangle. Okay, B3 by 2. B3 equal to 120 by 2 equal to 60 mm. So x3 equal to 60 mm. In similar way, y3 is the distance of a centroid C3 from x-axis. So y3 equal to depth of a height of a bottom rectangle plus height of a second rectangle plus half of the height of a third rectangle. So D1 plus D2 plus D3 by 2. Okay. Now here x1 equal to 150 mm, x2 equal to 110 mm, x3 equal to 60 mm. Okay, x1 equal to 100 plus B1 by 2, x2 equal to 100 plus B2 by 2, x3 equal to B3 by 2. Okay, x1, x2, x3 are the individual distances of centroid C1, C2, C3 from y-axis. Now y1 equal to D1 by 2, y2 equal to D1 plus D2 by 2, y3 equal to D1 plus D2 plus D3 by 2. Y1, Y2, Y3 are the distances of centroid C1, C2, C3 from x-axis. Okay. So here Y1 equal to 10 mm, Y2 equal to 50 mm, Y3 equal to 85 mm. Okay. Now I am considering these values in tabular form. Okay. Here I consider bottom rectangle as a section 1, middle rectangle as a section 2, top rectangle as a section 3. Okay. These are the corresponding dimensions. These are the individual areas, and x1, x2, x3 are the distance of centroids from y-axis. Y1, Y2, Y3 are the distances of centroids from x-axis. Already we know that xc is the distance of centroid or center of gravity of an entire z section from y-axis. Okay, a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. Okay, now you have to substitute the value. Now you have to substitute these values. After substituting these values, you can get the value of xc. Okay, xc equal to 114.54 mm. Okay. In similar way, yc is the distance of a centroid or center of gravity of an entire z section from x-axis. a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Okay. Yc equal to 41.36 is the distance of centroid CZ from x-axis. Okay. Now I will show the position of a centroid. Okay. So here, this is the origin. This is centroid C1, centroid C2, centroid C3. Okay, whereas C1, C2, C3 are the individual centroids. Okay, C1, C2, C3 are the individual centroids, whereas CG is the centroid of an entire Z section. Okay, CG is the centroid of an entire Z section. Okay, XC is the distance of centroid CG from y-axis, and YC is the distance of centroid CG from x-axis. Okay, XC, YC are the coordinates of the centroid or center of gravity of a Z section. Okay, let's consider this cross section for second problem. Look at the centroid or center of gravity of the given Z section. Okay, these are the given values. First of all, the given section is split up into three rectangles. Here, this is a bottom. Here, I consider this bottom rectangle as a section 1. The B1 is the base, D1 is the depth. Okay. Now, this middle rectangle as a section 2. Base 2 equal to 20 mm and depth 2. Depth D2 equal to 60 mm. Here, I consider this top horizontal rectangle as a section 3. This one is a base 3 equal to 120 mm and depth 3 equal to 10 mm. Okay. So these all are individual cross sections. Section 1, section 2, section 3. Okay. For locating the centroid or center of gravity, you have to consider reference x-axis and y-axis like this. Okay. Here, this is the origin. Okay. So this is a bottom rectangle. Let A1 is the area of a bottom rectangle. A1 equal to base into depth. Okay. That value equal to 100 by 20 equal to 2000 mm square. Now this is a base 2 equal to 20 mm and a base 3 equal to, sorry, depth 2 equal to 60 mm. So A2 is the area of a middle rectangle. That is a 20 by 60 equal to 1200 mm square. Okay. Here A3 is the area of a top rectangle. So base 3 equal to 120 mm, depth 3 equal to 10 mm. So A3 equal to B3 into D3. That value equal to 1200 mm square. Okay, these all are individual areas. A1, A2, A3 are the individual areas. Now I am considering the reference x-axis and reference y-axis. Okay, this intersecting point is the origin. Now you have to consider individual centroids with respect to origin. Okay. Now I am drawing the diagonals for locating the individual centroids. Now this intersecting point is the centroid of a bottom rectangle. Okay, C1 is the centroid of a bottom rectangle. X1 is the distance of a centroid C1 from y-axis. Okay. So that value equal to half of the base. In similar way, y1 is the distance of centroid C1 from x-axis. That value equal to d1 by 2. Okay. In similar way, you have to consider diagonals for this second rectangle for locating the centroid C2. C2 is the centroid of a middle rectangle. Okay. Now x2 is the distance of centroid C2 from y-axis. X2 equal to this gap 80 mm plus half of the base. Here base is 20 mm, so B2 by 2 equal 10 mm plus gap 80. So x2 equal 90 mm. In similar way, y2 is the distance of centroid C2 from x-axis. Okay. Here y2 equal to d1 plus d2 by 2. Okay. Now I am considering the diagonals for locating the centroid C3. C3 is the centroid of a top rectangle. Here x3 is the distance of centroid C3 from y-axis. Okay. Here this gap is 80 mm. So gap 80 mm plus half of the base. Here base 3 is 120 mm. So 120 by 2 equal to 60 mm. 60 mm plus 80 equal to 140 mm is the value of x3. Y3 is the distance of centroid C3 from x-axis. That value equal to height of a bottom rectangle plus height of a middle rectangle plus half of the height of a top rectangle. So that value equal d1 plus d2 plus half of the depth d3. Okay, 20 mm plus 60 mm plus 5 mm. Okay, that value equal to 85 mm. Okay, y3 equal to 85 mm. x1 equal to b1 by 2, x2 equal to b2 80 plus b2 by 2, x3 equal to 80 plus b3 by 2. Okay, in similar way, y1 equal to d1 by 2, y2 equal to d1 plus d2 by 2, y3 equal to d1 plus d2 plus d3 by 2. Okay, now I am considering these values in tabular form. So here section 1 is bottom rectangle, section 2 is middle vertical rectangle, section 3 as top horizontal rectangle. These are the corresponding dimensions. A1, A2, A3 are the individual areas. Okay, these all are the coordinates. Okay, coordinates of centroids. Already we know that x is the distance of centroid of an entire z section from y-axis. Okay, here x equal to 85.45, and here yc is the distance of centroid of an entire z section from x-axis. Okay, yc equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Okay, here yc equal to 41.36 mm. Okay, now I will show the position of centroid of an z section. Here this is the reference x-axis, this is the reference y-axis, this one is origin. Now C1 is the centroid of a bottom rectangle, C2 is the centroid of a middle rectangle, C3 is the centroid of a top rectangle. Okay, here C1, C2, C3 are the individual centroids, whereas CG is the centroid of an entire Z section. Okay, CG is the centroid of an entire Z section. XC is the distance of centroid CG from y-axis. YC is the distance of centroid CG from x-axis. Okay, so CG is the position of centroid. Okay, centroid of this given Z section. Okay, now this is the complete answer for this Z section. Now this is a problem, third problem. In this case, you have to look at the centroid or center of gravity of this given Z section. Okay, first of all, the given Z section is split up into 3 rectangles like this. Yeah, this one is bottom rectangle, this bottom rectangle. Okay, B1 is the base, B1 equal to 20 mm, and depth D1 equal to 80 mm. Here I consider this rectangle from here to here. Okay, you have to subtract this height 20 mm from this height. Okay, so the height of this bottom rectangle is 100 minus 20 equal to 80 mm. Okay, so D1 equal to 80 mm. Now you have to consider this horizontal rectangle as a section 2. Okay, so here base 2 equal to 10 mm plus 80 mm. Okay, 10 mm plus 80 mm. Total horizontal width is 90 mm, and height D2, depth D2 equal to 20 mm. Okay, now you have to consider this vertical rectangle as a section 3 from here to here only. You have to consider from here to here only. So therefore, the base B3 equal to 10 mm and depth D3 equal to height 100 mm minus 20 equal to 80 mm. Okay. Now for locating the individual centroids, you have to consider reference x and y axis. This is the reference x axis. This is the reference y axis. Okay. Now this intersecting point is origin. Okay. For locating the individual centroids, you have to use this reference origin. Okay, this is a bottom rectangle, base B1 and the depth D1 equal to 80. So the area of a bottom rectangle A1 equal to B1 by D1 equal to 20 by 80 equal to 1600. And this one is the second rectangle, base 2 equal to 90 mm and depth 2 D2 equal to 20 mm. So the area of a middle rectangle A2 is B2 by D2, that value equal 90 by 20 equal to 1800 mm square. Now this is the third section. So base 3 equal to 10 mm and depth 3 equal to 80 mm. So area of a third rectangle A3 equal to B3 by D3 equal to 800 mm square. So here A1, A2, A3 are the individual areas. Okay. Now for locating the centroid, you have to consider reference x-axis and reference y-axis. Okay. Okay, friends. For locating the individual centroids, you have to draw diagonal lines. Okay. So now I am drawing the diagonal lines for locating the individual centroids. Okay. This intersecting point is centroid of a bottom rectangle. Okay. C1 is the centroid of a bottom rectangle. Here x1, sorry, here the bottom gap is 70 mm. Here x1 is the distance of centroid C1 from y-axis. Okay. So here the gap is 70 mm plus half of the base. So gap 70 plus 10 mm equal to 80 mm is the distance of centroid C1 from y-axis. Okay. In similar way, y1 is the distance of centroid C1 from x-axis. That value equal to half of the height. Okay, d1 by 2. That value equal to 80 by 2 equal to 40 mm. Now I am drawing the diagonal lines for second section for locating the centroid. So C2 is the centroid of a middle rectangle. Okay. Here x2 is the distance of centroid C2 from y-axis. That value equal to half of the base equal to 90 by 2 equal to 45. And here y2 is the distance of centroid C2 from x-axis. Okay, y2 equal to height of a bottom rectangle plus half of the height of a middle rectangle. Okay, d1 plus d2 by 2. That value equal to 80 plus 10, 90 mm. Y2 equal to 90 mm. Now I am drawing the diagonals for this top rectangle. Okay, this intersecting point is C3. Okay, here x3 is the distance of centroid C3 from y-axis. That value equal to base 3 by 2. That value equal to 5 mm. Okay. In similar way, y3 is the distance of centroid C3 from x-axis. That value equal to height of a bottom rectangle plus the height of a middle rectangle plus half of the height of a top rectangle. Okay, d1 plus d2 plus d3 by 2. Okay, y3 equal to d1 plus d2 plus d3 by 2. x1, x2, x3. Okay, this one is x1, this one is x2, this one is x3. And this one is y1, this one is y2, this one is y3. Okay, now I am considering these values in tabular form. Okay, already we know that xc is the distance of centroid of an entire z section from y-axis. Okay, that value equal to 50.71 mm distance of centroid CG from y-axis. In similar way, yc is the distance of centroid CG from x-axis. That value equal to 80.47. Okay, here a1 equal to 1600 mm square, a2 equal to 1800 mm square, a3 equal to 800 mm square. Okay, x1 equal to 80, x2 equal to 45, x3 equal to 5 mm. Okay, here y1 equal to 40 mm, y2 equal to 90 mm, y3 equal to 140 mm. Okay, now I will show the position of centroid of an entire z section. Okay, this is the given diagram. Here you can observe C1, C2, C3 are the individual centroids. Okay, C1 is the centroid of a bottom rectangle, C2 is the centroid of a middle rectangle, C3 is the centroid of a top rectangle. Okay, whereas CG is the centroid of an entire Z section. Okay, CG is the centroid of an entire Z section. XC is the centroid of XC is the distance of centroid CG from y-axis, and YC is the distance of centroid CG from x-axis. Okay, this is the position of a centroid or center of gravity of a given Z section. Okay, friends. So here x is equal to 50.71 mm, YC equal to 80.47 mm. Okay, so CG is the centroid or center of gravity of this given Z section. Okay, with respect to this origin. In next class, I will explain about these two sections. Okay, in next session, I will explain how to locate the centroid or center of gravity of these two composite sections. Okay.